நெக்ஸ்ட் என்ன பார்க்க போறோம் அப்படின்னா சிம்பிள் தெரியல லோட். லோடுனா என்ன டிஃபைன் பண்ணோம் அப்படின்னு பார்த்தீங்கன்னா லோட் இஸ் த கம்பைன்ட் எஃபெக்ட் ஆஃப் த ஃபோர்ஸஸ். நிறைய ஃபோர்ஸ் ஆக்ட் ஆகுதுன்னா எல்லாத்தோட கம்பைன்ட் எஃபெக்ட் ஆஃப் த ஃபோர்ஸஸ் தான் வந்து லோட். கம்பைன்ட் எஃபெக்ட் ஆஃப் த ஃபோர்ஸஸ். ஓகே, இந்த லோடு வந்து யூஸ்வலாக பாயிண்ட் லோட். பாயிண்ட் லோட் is act at a point, concentrated load. Next, uniformly distributed load or rectangular load. Then uniformly varying load, that can be called as triangular load or non-uniform load. When we are having them, when the load is acting at a point, it is called as point load or constant load. When we are having a beam, the load is fully acting. It is a rectangular load. This is the triangular load. And the non-uniform load. Non-uniform load. So totally we are having 4 categories of load. Next we are going to know about the area. Area can be normal area or tangential area. So we are having load here. We are calculating this area. This area is the normal area. It can be noted as normal area because this area perpendicular to application of load. Perpendicular to application of load. The area parallel to load, application of load. So here we are having load is applied. So this area is parallel to the application of load. That area can be called as tangential area or we can shear area also. அடுத்து என்ன பார்க்க போறோம்னா லோட் தான் பார்க்க போறோம். லோட் வந்து நம்ம ரெண்டு வகையா பிரிக்கலாம். டைரக்ட் லோட், indirect load. Direct load வந்து பாத்தீங்கன்னா axial load, shear load. Indirect load பாத்தீங்கன்னா bending load, torsion load, twisting load or torsion load. So axial load la again நம்ம பார்த்தோம் அப்படின்னா tensile load, compressive load. So these are different types of load based on the direction of load application. So axial load, it is applied on the axis. Shear load, it is applied tangentially. Bending load, it is perpendicular to the axis. Twisting load, we are applying circumferential to the axis. This is perpendicular when the load is applied perpendicular to the axis, called bending load. When the load is applied circumferential, we can say that it is torsion load. When the load is applied on the axis, this load is applied on the axis away from each other, it is called tensile load. When the load is applied on the axis towards each other, it is called as compressive load. When the load is applied tangential to the axis, it is called as tangential load or shear load. So based on the, when it is applied on the axis, this is the axial load. when the two loads are acting away from each other, tensile load, towards each other, it is compressive load. When the load is acting tangential, it is called shear load. When the load is applied perpendicular, it is called bending load. When the load is applied circumferential, it is called as torsion load. Next பார்க்க போகிறது stress, types of stress. Stress வந்து again வந்து it can be given into direct stress and indirect stress. Based on the load applied, it can be given to axial stress and shear stress, tensile stress and compressive stress. This indirect stress is bending stress, torsional stress. So these are the types of stress. Based on the different types of load, we are having different stress. When you define axial stress, when the load is applied axially, the resistance offered by the body per unit area when the load is applied axially. Define shear stress, the resistance offered by the body per shear area when the load is applied tangentially. Tensile stress, when the load is acting away from each other, the resistance offered by the body when the load is acting away from each other per unit area. Define compressive stress, when the load is acting, the resistance offered by the body per unit area when the load is applied towards each other. Shear stress, already we have discussed. Bending stress, the resistance offered by the body when it is subject to the bending load or transverse load. Torsion stress, torsion shear stress, the resistance offered by the body when the load is applied circumferentially. So these are the different types of stress. Next, we are going to know about the strain. Strain is the defined as the deformation per unit length. Change in length by unit length or deformation. This thing called as deformation, or we can deformation per unit length. Strain will be notated by delta K. This strain can be axial strain, shear strain and volumetric strain. Axial strain can be again converted into tensile strain and compressive strain. Here tensile strain is change in length by original length. This is increase in length. Here also change in length by original length. Here length will be decreased. Here length will be increased. Shear strain. Shear strain, it is the angular deformation. Volumetric strain, change in volume by original volume. So these are the different types of strain we can observe. Generally, strain can be notated as change in length by original length or delta by L. It can be divided into axial strain, shear strain, volumetric strain. So these are the important things to remember in strain. Next, we should know about the tensile stress. Tensile stress is tensile load by area. Can be tensile load by area. Again, compressive stress. Compressive stress, you can get compressive load by area. This area is the cross-sectional area or normal area. Next is we are going to know about the shear stress. Shear stress is protected by tau. It is shear load by shear area. Shear load by shear area. Next is bending stress. Bending stress is sigma my by I or m by s. This is the ratio of bending moment to the top section modulus. The ratio of bending moment to the top section modulus is known as bending stress. This section modulus we can discuss later. It is the ratio of moment of inertia by distance in the neutral axis. Next thing we are going to discuss is torsional stress or torsional shear stress. It noted as tau. We can say that P or T by Z suffix P. Z suffix P is the polar section modulus. It is the ratio of polar moment of inertia to the rough radius. 8 unit is meter cube. So our torsional shear stress can be defined as the ratio of twisting moment to the top polar section modulus. We are having strain. The types can be divided into linear strain or lateral strain. The lateral strain also called as transverse strain. Linear strain also called as longitudinal strain. For example, we are having a body, it is applied tensile load. What happens? It will increase in length. So length will be increased. This length is increased. It is the one way of strain. And similarly, it decreases in this thickness, dimension. For example, this here, this is B. So this when it is increased in one direction, in other direction it will decreases. The strain measured along the loading direction, strain measured along loading direction is termed as lateral strain. The strain measured perpendicular to loading direction is called as transverse strain. So transverse strain also called as lateral strain. Next we are going to know about the Hooke's law. Hooke's law find out the relation between stress and strain. Stress is directly proportional to strain. When you want to remove the proportionality constant, it is equal to Young's modulus times of strain. This is the Hooke's law. Stress is directly proportional to strain. Up to proportional limit is the right answer. Proportional limit is the right answer. So when you extend, in some cases they will put elastic limit also. When proportional limit is not available, you can put elastic limit as the answer. This is the Hooke's law. Hooke's assume that my material is here. Material is homogeneous and isotropic. He find out the relation by selecting the homogeneous material and isotropic material. It is the important assumption in the Hooke's law. Next is Young's modulus. This Young's modulus is find out with the help of Hooke's law. We already know that stress is proportional to strain. So when you want to remove the proportionality, you have to put the constant. That constant is Young's modulus. Young's modulus is the ratio of stress by strain. Its unit is Newton per meter square. Since it has Newton per meter square here, meter by meter or no unit. Next we are going to know about the shear modulus or modulus of rigidity. Young's modulus also called as modulus of rigidity. Young's modulus also called as modulus of elasticity. Shear modulus also called as modulus of rigidity. You know that shear stress is proportional to shear strain. Shear stress, when you want to remove the proportionality or constant, then D is the ratio of tau by gamma. So here Newton per meter square, no unit. So it is the ratio of shear stress root of shear strain, can be called as shear modulus or rigidity modulus. Next thing we are going to know about is bulk modulus. Bulk modulus, when the direct stress is proportional to the direct strain or volumetric strain. It can be, is the bulk modulus ratio of direct stress root of volumetric strain, or we can say that it is equal to pressure by volumetric strain. This pressure is hydrostatic pressure. The ratio of hydrostatic pressure to the top volumetric strain. Its unit is Newton per meter square. Next is, we should know about the Poisson's ratio. This Poisson ratio is noted by mu, or in some book nu. Is the ratio of lateral strain by linear strain. Lateral strain also called as longitudinal strain by linear strain also called as transverse strain. When the load is applied in one direction, the strain take place in other direction is negative. So in some cases we can say this is minus epsilon LA. Or if you does not consider direction, we can simply put it as plus also. In both the cases, it will okay. Based on the available option, we have to decide. That is a Poisson ratio. Next thing we have to know that these four E, G, K and the mu are called as elastic constant. This is very much important. We already know one by one. எல்லாமே எப்படி யூஸ் பண்ணோம்னா இதெல்லாம் எலாஸ்டிக் கான்ஸ்டன்ட் அப்படின்னு சொல்லுவாங்க. ஸோ மூணு பேர் மாடலஸ் இருப்பாங்க, இவர் வந்து மியூ. ஸோ பாய்சான் ரேஷியோட சேர்த்து மூணு மாடலஸ் சேர்த்து எத்தனை பேர் இருக்காங்க? 4 பேர். கும்கி பாட்டு ஞாபகம். யானையோட சேர்த்து நாங்கள் 4 பேருங்க. 3 பேரும் மனுஷங்க இருப்பாங்க. கும்கி படத்தில் 3 மனுஷங்க இருப்பாங்க, கூட ஒரு யானை இருக்கும். அதான் யானையோட சேர்த்து நாங்கள் 4 பேருங்க. அப்படின்னா Young's modulus, rigidity modulus, bulk modulus, and Poisson ratio. These are the elastic constants we should remember for the design purpose. Next நம்ம பார்க்க போறது என்னன்னா volumetric strain. Volumetric strain. Volumetric strain na you can notice some of the three principal strain. Some of the strain take place in the all the direction. For cylinder, it can be represented 2 times of circumstrain plus 1 times of longitudinal strain. This is for cylinder. For sphere, this volumetric strain equal to 3 times of circumstrains. For cube, it is equal to 3 times of axial strain. So these are the important formula you have to remember for the volumetric strain. Next நம்ம என்ன தெரிஞ்சுக்கணும்னா some of the important formulas. Stress க்கு வந்து load by area. Stress ஓட யூனிட் வந்து strain க்கு வந்து change in length by voltage length. Poisson ratio R equal to lateral strain by linear strain. Young's modulus equal to direct stress by direction. Rigidity modulus equal to shear stress by shear. Bulk modulus equal to volumetric stress by volumetric strain, or direct stress by volumetric strain, or pressure by volumetric strain. So these are the basic formulas we have to remember for the stress and strain and elastic constant. When I talk about number of independent elastic constant, number of independent elastic constant for different material. என்னென்ன மெட்டீரியலுக்கு கான்ஸ்டன்ட். ஃபர்ஸ்ட் ஐசோட்ரோபிக் மெட்டீரியலுக்கு 2, ஆட்டோட்ரோபிக்கு 9, அனிசோட்ரோபிக்கு 21. These are independent elastic constants. இது வந்து total number of elastic constant கேட்டாங்கன்னா ஐசோட்ரோபிக்கு 4 total. Independent 2. So அது ஞாபகம் வச்சுக்கணும். This is a get any question.